Okay, and then so that covers all of our proportion stuff. So the key there is that when we're dealing with confidence intervals and hypothesis tests for proportions, we are using Z. We're using the normal distribution table. We're looking up Z-scores and things of that nature. Okay, so all of those formulas are kind of summed up right here. Also, if you use the guide for inference, all of those things also show up here as well. So, you know, for the proportions, you know, it's kind of written out with words over here. So depending on what style is better for you, use whatever you feel more comfortable with. You don't have to use one or the other, okay? So, you know, if the observed value is going to be p hat minus p hat 2, you know, and your standard error is this way. So it's written out in both cases, however you want it presented there. Okay, so then we've got, now we're dealing with means, okay? So we'll cover confidence intervals for one sample, and we're dealing with means here, okay? So in here, our formula is x bar plus or minus t star times our standard error. The data we need will be the sample mean x bar S, which is our sample standard deviation, and N, which is our sample size. Okay? And from that, we can do our calculations. Our standard error is equal to S divided by the square root of N. And to get our T star, needs the confidence level and our degrees of freedom. And degrees of freedom is equal to n minus 1. Okay? So then you look T star up in the T table. Okay? For all confidence intervals, the standard error is this part, and then the margin of error is going to be your critical value times the standard error. So if we're talking about proportions, it's Z star times the standard error, and for means, it's T star times the standard error. That's going to be your margin of error. Okay, and that's how we make our confidence interval. If we're going to make confidence intervals for two samples, and we're dealing with means, we've got the formula will be x bar 1 minus x bar 2. This is what goes into our center, the center of our interval, plus or minus t star times our standard error, okay? The data needed this time, we've got two samples. We've got sample 1 and we have sample 2. And we're going to need an x bar from sample 1, an s from sample 1, and an n from sample 1. We'll also need an x bar from sample 2, an s from sample 2, and an n from sample 2. As far as calculations go, our standard error is given by this formula, s1 squared over n1 plus s2 squared over n2. If you take the step to label all of your data pieces, this part's going to be easy, okay? If you skip this step, it's easy to get mixed up and plug the wrong values here and there. Okay, so you plug that in, and again, T star needs the confidence level. And degrees of freedom equal to n minus 1, okay? But we have two n's. So what do we do? Yeah, so we use this, the smaller n. Okay, so you have this, you take the smaller n, you plug that in, and there you go. Okay. And then lastly, we've got hypothesis tests. So we've got hypothesis tests. One sample means, okay, our null hypothesis is always going to be mu is equal to some number, which we say is mu 0, but keep in mind mu 0 is just some number. So an example would be that the null hypothesis is that mu is equal to 42. The alternative will be that mu is not that number, or mu is greater than that number, or mu is less than that number. Okay, so it could be so those are your hypotheses. The data you need will be x bar, s, and n. As far as calculations go, your standard error is s over the square root of n. And your test statistic t is going to be x bar minus whatever mu 0 you have in your null hypothesis divided by the standard error. Okay, and then you go to, you look up t in the t table. Okay. Use the row df equal to n minus 1. Okay, so figure out your degrees of freedom, use that row. If that row doesn't exist, always round down. Okay.
What if the row does exist?
Then use that row. Okay, so if the row does exist, great, use that row. Okay, if it doesn't exist, if it does not exist, then round down. Okay, and then generally your t will be between two values, or maybe on one side, and then that means your corresponding tail area is between the column headings. So t will be between two values. Okay, and then your corresponding tail area will be between the column headings. Otherwise, your t will be bounded on one side by, by the table, okay? Or t will be bounded on one side only. Okay, and then just kind of the sanity check will be that large t values correspond with small p-values. And small t goes with big p-values. Okay, so if you have a large t, meaning extremely large positive or extremely large negative, okay? So, you know, anything larger than 3 or 4, that's going to be a large t, okay? Those are going to go with small p-values. Smaller t's, so t's less than 1 or 1.5, those are going to go with large p-values. Those are kind of good rules of thumb. Okay, that's one sample, and then, excuse me, for 2 samples, it means you've got the null hypothesis being mu1 is equal to mu2, or conversely, it can be written as mu1 minus mu2 equal to 0. The alternative will be mu1 is not equal to mu2, or mu1 is greater than mu2, or mu1 is less than mu2. Okay, and this corresponds to mu1 minus mu2 not equal to 0, etc., etc., etc. Okay, data needed. X bar 1, S1, N1. X bar 2, S2, N2 from sample 1, sample 2. As far as your calculations go, you'll need the standard error. Same standard error as the one you use for confidence intervals. S1 squared over N1, S2 squared over N2. Your test statistic t is going to be x bar 1 minus x bar 2 over the standard error. And then again, to go from a t, you look up the t in the t table to get the p-value. Okay. Use the row with degrees of freedom equal to n minus 1, and use the smaller n between n1 and n2. Okay, so this is kind of just a recap of all of the confidence intervals and hypothesis tests and stuff that we've covered in this class. Again, I have all of this information on your guide for inference, or this kind of formula sheet, okay? And so for the final exam, you are allowed 1 sheet of notes with writing on the front and back. If you want to use either papers that I've given to you, that's fine. Make your pick, and then you can fill out writing however you want. That's up to you. If you don't want to use those, that's also fine. You can write everything out by hand yourself, and maybe you can cram everything into a smaller space if that's what you want. So that's there. So next week, please work on the practice final. We're going to go through the entire practice final exam together as a class. And that's it. We'll see you guys next week. Yes. Yeah. So.